Genome sequencing has recently gone through a revolution, and so at this point we can sequence a human being in basically no time, but now the main challenge is that we need ways to understand and interpret these variants. I'm specifically going to focus on variants in proteins. Proteins are only about 1% of the human genome, but they carry out many of the important functions in our bodies, like for example transporting oxygen in the blood, so they're a very important 1%. The goal of my work is to understand both which variants will have an effect on health and disease, and then also how on the molecular level they have this effect. Because if we understand the underlying mechanism, that will allow us to develop therapies. The fellowship will allow me to both improve modeling of proteins, but also very importantly to generate our own data to see which effects all these different variants have, because I think to make fast progress in this area, it's very important to have feedback between the modeling component and the experimental aspect, so that we can much more directly see, well, this part of our modeling works, but this other part still needs to be tweaked. And that's really, I think, only possible if you have both aspects covered in the same or very closely collaborating labs. My background and training is in computer science and bioinformatics, and I spent quite a lot of time in my PhD and first postdoc developing methods to model proteins. And one reason why I changed the focus of my work was that there was a very premature death in our family, and that made me realize how important it is to do work that will benefit the current generation. And then the other reason is that I now have a little daughter who's called Melanie and who the project is named after. And of course I would like my work also to benefit her generation.